Hello. Hey, everybody. How are you? Good to have you back. Welcome to the channel. Welcome to another math video. So let's talk about fish today. What's the best way to contact the fish? WhatsApp. Ha 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 ha. I'm joking. You dropped them a line. Ha, ha. Okay. Today we are looking through applications of deriving exponentials. So we've just learned how to derive the differentials, derive differentials, derive exponentials. And so when we talk about the applications, essentially we're just talking about finding gradients or equations of tangents and normals. And we're also, one of the applications of differentiating is curve sketching. So things like stationary points, min, max, intercepts, sometimes even domain and range, all that kind of stuff. So we're just going to go through a couple of examples, and I'm going to do my best to kind of zoom through them. Okay, so find the equation of the tangent and normal for y equals x plus e to the x at x equals to 1. Hopefully you've seen me say this enough times. If I'm trying to find the equation of the tangent, I'm going to use this: y minus y1 equals to m x minus x1, because that's how you find the equation of a straight line. Now, I need a couple things. I need a point and I need a gradient. So I've got x equals to 1. I'm going to substitute x equals to 1. So y is going to equal to 1 plus e to the 1, and that's just 1 plus e. So substituting it back into the original. Right, so now that I've got a point, all I need now is the gradient. So how do I find the gradient? Well, I use my derivative. So if I derive this, y dash is going to become 1 plus e to the x, and I hope you remember that e to the x, when you derive it, just becomes e to the x. So gradient of my tangent is going to be what happens when I substitute 1 in. So my gradient of my tangent is just going to be 1 plus e. And so the gradient of my normal while I'm here is going to be -1 on 1 plus e. The reason I know that is if I multiply them together, I should get -1. So I'm thinking negative reciprocal to find my gradient of my normal so that they're perpendicular, right? Because m1 times m2 should give me -1. That there's the rule for perpendicular, right? So the normal tangent, in other words. So now that I've got that, let's plug it in. So it should be y minus y1. So in this case, the value for y1 is 1 plus e. Yeah, y minus y1. Be careful with your brackets here. Equals to m. So let's do tangent 1 plus e. And then m x minus x1, which is just 1. So let's just clean this up a little bit. Y minus 1 minus e. This becomes x minus 1 plus ex, but not exponential, just ex minus e. Now let's see what we can do if we clean things up a little bit. Plus 1 to both sides, that will cancel out. Plus e to both sides, that'll cancel out. So I'm just left with y equals x plus ex. And so if you really wanted to, this could be y equals 2. Take out a factor of x, and it will be 1 plus e. And that there would be your equation of your tangent at that particular point. And then if I was to do the same thing here for the equation of the normal, it would just be y minus y1. So same point, y minus y1. Don't forget the brackets. So I probably should clarify here that this is tangent on this side. And I'm going to find the normal on this side. So y minus y1 equals to m. And this time, instead of using the 1 plus e, I'm going to use the gradient of my normal, which I found out was -1 on 1 plus e. And then it's going to be x minus 1. And here, it's not going to be very nice. So I'm just going to expand everything here. I'm going to have 1 plus e y, take away 1 plus e squared minus x plus 1. I'm just going to push everything over to the other side. So I'm going to have x plus 1 plus ey minus 1. I'm going to need to make some room here. Minus 1 plus e squared minus 1 equals to 0. If I really wanted to, I could expand it out, but I'm happy to leave it there for the time being. Okay, so that's tangent, that's normal. All kind of hinges on this and using your first derivative to get your gradient of either your tangent or your normal using the particular point they've given you. Hopefully that's not too bad. Now let's try a question like this. We want to sketch y equals x e to the negative x, showing stationary points and points of inflection. So let's take a look at this one here. First things first, how do I find a stationary point? I need to let y dash equal to 0 and solve. So let's take a look here. We've got y equals e to the negative x. That there is a product. I've got x times e to the negative x, so I'm going to have to differentiate this using the product rule. So u is going to equal to x, v is going to equal to e to the negative x, u dash is going to become 1, and v dash is going to become, so the negative will come out the front, it'll be negative e, and then your power of your exponential stays the same. So that means here, y dash would equal to e to the negative x. Well, it's going to be minus because of the minus e to the negative x. So it's going to be minus x e to the negative x. So that there is your first derivative. Now, how do we let that equal 0? Right, so I'm going to try factorize it here. I can see e to the negative x is a common factor, and it's going to leave me with 1 minus x. Now, what's nice is I know that e to the negative x will never become 0, but the second bracket will. So I can see here that x would equal to, when x equals to 1, it's going to turn that bracket into 0. So that there would be my solution, and I have a stationary point at x equals to 1. All right, now remember, we're talking about stationary points, so I don't just need the x, I also need the y. Substitute back into the original. So it's just going to be 1 times e to the negative 1. So in other words, this is just y equals to 1 on e using your negative index laws. Okay, so now I've got a point, I've got a stationary point. I just need to prove whether it's max or min. So this is going to be a little bit gross. So what I'm going to do is I'm just going to figure out what happens if I plug it in on either side using my table of values here. So we know x equals 1, there's a stationary point. So if I take a look at this, x, I have 1. I'm going to test a point on either side. I'm going to test 0 and 2. And the other thing that I want to substitute it into is my y dash. Okay, so most times I would use my y double dash, but I'm looking at this and I don't want to use the product rule again to get my y double dash. So I'm just going to use my table of values. So I'm going to substitute it into y dash. If I have 0, it will be e to the negative 0 minus 0 e to the negative 0. So that's just going to be 1 take away, that's going to be 1 take away 0. So that's just going to equal to 1. So in other words, it's positive. If I substitute in 1, I know this is going to come out with 0. And then if I substitute in 2, I will get e to the negative 2 minus 2 e to the negative 2. So it's going to become negative e to the negative 2, which is going to be a negative value. All right. So what we can see here is this: there's a positive gradient, there's a 0 gradient, and there's a negative gradient. So I can see that this here is actually a max stationary point. It's actually a max. So now we know it's a max stationary point. Let's double check, I guess, where the point of inflection would be. So it looks like we do have to use our second derivative. Not going to be fun. I don't want to change that. I don't want to do that. Should I do it? It's going to make the video so long. Points of inflection. All right, I'm going to do y double dash. Okay, so it's going to be e to the x. Derivative of e to the x is going to be negative e negative x. And we know that the derivative of x e to the negative x is going to become, I'm just going to use a cheat here, e to the negative x minus x e to the negative x. Okay, so that there is what our second derivative should be. And if we were to clean this up a little bit, we have minus e to the x minus e to the x. So that's going to be minus 2e to the negative x. And we're going to have plus x e to the negative x. How do you find your point of inflection? That y double dash equal to 0. And then so we're going to let that equal to 0. Okay. Now solving here, I can see that e to the negative x is going to be your common factor. So it's going to be leave me with minus 2 plus x equals to 0. And so I can see here that x would have to equal to 2. And then to make it a point of inflection, y would be substituted back into the original. It just becomes 2e negative 2. So that there becomes your point of inflection. Okay, so now putting everything together. Okay. Now we have a stationary point at 1 and 1 on E. 1 on E. So that's 1. 1 on E will be there. Let's say that's 1 on E. That's E. So that there is going to be a max point. Okay. We also have a point of inflection at 2 and 2e negative 2. So we're going to have 2 and then 2e negative 2. And then what I'm going to test here is I'm going to test and see what happens as I let x get really, really large, because I can see that it's probably going to do something weird here. How do you find a y-intercept? Let x equals to 0. So in this case, I can see that it's just going to cut through 0. But I've got a feeling that if I sub test as x gets really, really large, and I put it into my original, so we've got y equals to x e to the negative x, x e to the negative x. So let's see what happens if I say y equals to, let's say, 1,000 times e to the negative 1,000. Test and see what that gets you. It will either be a small number or a large number. This is what happens when I don't test my questions before I start. So I'm just going to put in 1,000 times e to the power of negative 1,000. And I'm assuming that this is going to reach 0. Yeah, it's going to reach 0. So it just means that as we get larger and larger, it's going to look a little bit like this. And it's actually going to have an asymptote, and it's going to approach 0 there. So this would be 2. And this one would be whatever the other thing was. But yeah, that's it. Hope you enjoy, and I'll catch you later. Oh, is that it? Yeah, I think that's it. All right. Enjoy. Nice long video. All right. See you later. Bye bye. Oh, wait. I think. What is E? It'll probably help understanding what E is, wouldn't it? Oh, no. I just wrote it wrong. Yeah, that's right. That's 1. Yeah, that's fine. So that's 2. And then this is going to be 2e negative 2. I don't have room for it, but that one there would be 2e negative 2. So yeah, that's fine. That's it. I'll stop it there and I'll catch you guys later. Bye bye.